So for lesson 4, it's kind of like this big topic of scatter plots and trend lines. That's today's lesson. But there are a couple other topics that go with that topic. So we split it up into part A, part B, and part C. Today and tomorrow we're going to be focusing on part A. So I'm changing your homework log ever so slightly. Thursday, we will be doing part B and C because they just go very nicely together. And then Friday, you're going to be doing an activity that has mostly to do with part C. But there's a lot of vocabulary that goes with this because we've been doing lessons 1, 2, and 3, kind of reviewing what you know about statistics already, mean, median, mode, that kind of thing, and then analyzing it, so taking it one step further. Today we're going to be starting some new material with new concepts and things like that. So let's start with a scatter plot. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. So, for example, your height and your foot size, which is what you guys are going to get from me tonight and bring it back for tomorrow. So we're going to display you as an ordered pair. X is going to be your height, Y is going to be your foot size, I think, and then that dot, wherever it is, represents you, okay? Two different sets of data. By displaying okay, so it pretty much looks like when we have graphed before, just a regular graph, like when we've graphed equations before from a table. Usually we would graph the dots and then connect them with a line or a smooth curve depending on the shape, but it always makes like a really nice consistent shape. Scatter plots, you graph it the exact same way, but it doesn't always make that nice consistent shape. So you might have one dot here, you might have one dot there, here, 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 here. So it basically is a bunch of dots that are scattered throughout the graph. Now, with a scatter plot, we leave it as discrete data, obviously, because each point represents a different person or a different piece of data. What we are going to be doing is trying to take that data and fit a line to most of the points to best represent so that we can make predictions. So we call it a trend line or a line of best fit because it's the best that we can do with the data. So it's close, or as close as we can get. So that's your second definition, is a line on a scatter plot that shows the correlation most accurately. So I'm going to draw another scatter plot. So we're going to do a scatter plot. Let's say our scatter plot data looks pretty linear. So in general, they kind of go like this. Okay? Kind of like a path. So the trend line would be a line that maybe goes, we want it to be as close to as most data points as possible. So the trend line or line of best fit would maybe go through like that. Okay? So it's basically the line showing the general trend of the data. Sometimes your data might be pretty tight and you might be obvious kind of where the line will be. Sometimes if your data is like what we did in the previous box in the red, and it's all over the place. Our trend line goes through as close to most of the data points as possible, but it still doesn't look very close, but it's the best that we can do. So the line of best fit or the trend line, we use those terms interchangeably, is just a line that best represents the data on a scatter plot so that we can make some predictions, which are our next two definitions. So the reason we do all of this stuff is to make predictions about the data. There are two types of predictions we can make: interpolation and extrapolation. Both of these words have the same suffix, polation meaning like making a prediction, but they have different prefixes, inter and exter. What do you think interpolation means? What does inter kind of sound like? Internal.
Forever.
Eternity. No, different. Interpolation is like internal guessing. So you're using a trend line to estimate a value between two known values. So it's using a trend line to estimate a value between two known values. I don't have an example for that, so you can leave it blank. But let me give you an example. So remember how last week we did your heights all in centimeters? Let's say AJ was absent that day, and we did everybody else's heights in centimeters. And we created an equation that represents the average height of boys in the class. Is AJ an outlier? Is he like super taller than everybody else or super shorter than everybody else? He falls within data that we already have, right? So we could use the equation to estimate what AJ's height is based off of whatever other measure that we use, because he is between two known data points. So we know that AJ is between Christian and David's height. So we could estimate using our equation how tall AJ is, because he lies within our data set. Now, Jonah wasn't here that day. Is he an outlier? Okay. He's taller than everybody, all the other boys in the class, right? So predicting Jonah's height would be what we call extrapolation. So making predictions from someone that is outside the range. So using the trend line to predict a value outside the range. Okay, so interpolation is estimating a value for a piece of data within the range that maybe we don't already have. Extrapolation is predicting something that's outside the range. So the example that we're going to do in class today is baby pandas, and using data that their height, their age and their weight. So using data that's given of a baby panda's weight based on its age, but we only measure like every other month. So to interpolate data would be estimating the weight of a panda on one of the months that we didn't measure, so within our range of data. Extrapolating would be, okay, using this, if the trend continues, how heavy will the panda be when it's 5 years old? So looking into the future. Does that make sense? So interpolation is within the range. Extrapolation is predicting outside of the range. Last two definitions. How many of you guys have heard of the word correlation before?
I've heard it in a movie.
Okay, that's okay. But like when we say something correlates to something else. So when we say that the, I don't know, I'm trying to think of what we're doing.
I was thinking of Frozen.
Oh, Frozen?
Coordinate.
Correlation is a relationship that two things have. So, for example, your age and your height could be correlated. Okay? So the older you are, the taller, in theory, you are. Does that make sense? Mm-hmm. So those two things are correlated. Two things that are related to each other. Now, just because two things are correlated does not mean one causes the other. So does your age cause you to be taller?
No.
No. But you could say that they are correlated, meaning typically the older you are, the taller you get. Okay? Two things that would imply causing something else, or what we call causation, would be the amount of rainfall and the number of potholes in the street. So potholes are caused by rain corroding the things in the street. So you could say that the amount of rainfall causes there to be more potholes in the street. Okay? Sometimes things have a very strong correlation, but you still can't assume that one causes the other. So you could say, like, what we're going to do tomorrow is your height and the length of your foot. So that's what you guys are going to measure for me tonight. You should, when we do the project, find a correlation between those two things. But how tall you are does not cause your foot to be a certain length. Does that make sense?
Yes.
So they're related, but one does not cause the other. What Lily was saying is, so there's a way to determine how strong a correlation is. And we're going to do that using the correlation coefficient. So how close your data points are to your line of best fit is what determines the strength of a correlation. Okay, so the stronger the correlation, the closer they will be to forming a straight line. Okay, and we use the correlation coefficient to determine that. The correlation coefficient is a number between -1 and +1. Okay. That tells you how closely the equation of the line of best fit models the data. Or equation of the line of best fit. Are you guys okay with that? LOBF, line of best fit, models the data.
Red, orange.
The correlation coefficient is represented by the letter R. So whenever you see R, that's your correlation coefficient. It stands for residual or regression, which we're going to get to later. Okay, but that's where the R comes from. So -1 is the smallest it will ever be, and +1 is the biggest. And I'm not putting equal underneath because if it's at -1 or +1, that means a perfect straight line. Okay, so exactly 1 or -1 means a perfect straight line. We're going to have some examples of this, but just so you guys know before we even do anything, the positive and the negative just has to do with if it is a positive correlation or a negative correlation. And positive is not necessarily better than negative. All that it means is the slope of your line. Okay, so if we're looking at your age and your weight, so typically, as you get older, you weigh more. So we would call that a positive correlation. As your age increases, your weight increases, right? Typically. I mean, usually by the time you reach adulthood, you level off. But as your weight or your age increases, your weight increases. So both are increasing at the same time. So that would be a positive correlation. So our correlation coefficient would be between 0 and positive 1, okay, because it's positive. A negative correlation would be it's hard to think of one that's not like money based. So like insurance.
Wait.
So if you guys think of this like car insurance, the longer you go without an accident, typically your rates decrease. Okay, so does that make sense? So the more amount of time that you go without having an auto accident, your insurance rates tend to very slightly, it's not a lot, but very slightly decrease. So you have to pay less because you are showing that you are a more reliable driver. Does that make sense? That is a negative correlation. So the more amount of time that passes without an accident, the lower your rates go. So as one increases, the other is decreasing. Make sense? So your correlation coefficient would be between 0 and negative 1. So the positive and negative just has to do with, is it a positive correlation or a negative correlation? One is not better than the other. What we are really looking at is how close is it to 1, either 1 or negative 1. The closer to negative 1 or the closer to positive 1 your correlation coefficient is, the straighter a line your data makes. Okay, if it's totally all over the place, like this one right here, that would be like 0.05. Like not even close to 1 because it's just all over the place. This orange one that we made is positive, so our correlation coefficient would maybe be something like 0.9 because it's pretty close to forming a line already. Does that make sense? So the tighter to align your data is, the closer your correlation coefficient R will be to 1 or negative 1 if it's going down. I'll show you some examples, okay? Back in the day, the very first year we taught this class, I had my classes calculate the correlation coefficient by hand. It is a lengthy process, and the equation, I'm sure I can find it for you guys tomorrow, like takes up a whole page. Like it would take a whole page for them to do it by hand. Desmos does it for you now. But really what you guys are going to be doing, and it's in your notes, so I'll show you in just a second. I'm going to give you a scatter plot, and then I'm going to give you 4 options for the correlation coefficient, and you just have to estimate it. So it's going to be pretty easy. But you need to understand what it means, like what the number actually means. Okay? Last thing that we're going to talk about is causation, and I already kind of touched on this. Causation is when a change in one quantity and here's the important part, causes a change in a second quantity. Okay. And then here's something really important I want you guys to write down. Correlation, does not equal causation. Okay? Just because something is correlated does not mean we can assume that one causes the other. Okay? An example of something that you can assume causes something else. Rain causes puddles. Okay? I think that's a safe assumption. But if we went the opposite way and I say there's lots of puddles on the ground, therefore it definitely rained last night, can you assume that? No, because it could be that your sprinkler broke and you have a bunch of puddles on your concrete now or in your grass because your sprinkler broke. But we can say, it's raining a lot, therefore my grass will have puddles on it. Does that make sense?
Yeah.
So you have to kind of use, this is really hard because it requires logical thinking. And sometimes the answer is not crystal clear. Like, you can make arguments for either one. So this causation piece is very, very tricky. Okay? Those are all our definitions for the lesson. So let's talk about right now scatter plots and correlations. So we're going to go back to just the very beginning of what we were talking about. Scatter plots. So it's basically looking at bivariate data, or data with two pieces represented as ordered pairs. So I put 3 scatter plots on your notes for you at the very top. And the way that we describe scatter plots are by their correlation, or the correlation that they show. So when y tends to increase as x increases, that is called a positive correlation. So x is increasing and y is increasing, so it's positive. Okay, and I already gave you an example of that. Your age and your weight tend to be positively correlated, especially from birth to about 18 years old, okay? Or another one would be your height and your weight. So taller people tend to weigh more because they have more body mass. A negative correlation is when y tends to decrease as x increases. So as x gets bigger, your y is getting smaller. That is a negative correlation. So the hard thing that you guys need to make sure you get out of your head is that negative equals bad. In this case, negative does not equal bad. It just means that one of your data points is decreasing as the other one increases. So your length of time without a car accident and your insurance rates. Okay? So the longer I go without an accident, the lower my insurance company is going to charge me. Okay, that's negative correlation. It is not a bad thing. When x and y are not related, the two sets have no correlation. So something that has no correlation. Your age and the number of hairs on your head. Okay, do you think those are correlated? Maybe when you're a baby, but otherwise not so much. Okay, or when you get really old. But as a teenager, maybe not. Or we could say your height and the number of pens in your backpack. Do those have anything to do with the other one? How tall you are and how many pens you own? No. So that would be, but you can make a scatter plot of that data. I could poll every single one of you, ask you how many pens you have in your backpack and how tall you are, and we could make a scatter plot of that data. It would be all over the place because your height has nothing to do with how many pens you own. Does that make sense? So that would be no correlation. But we're going to look at number 1 and we're going to just make a scatter plot. Okay? So I gave you some data that shows the number of dollars you spend and the amount of gallons you can buy of gasoline. This is relevant because gas prices are going down. Okay, so let's look at this. Let's have dollars spent be on our x-coordinate. So dollars spent is going to be our x-coordinate. And on mine, I did them by 2s. So we're going to say dollars spent. And then I went by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20.
And we need to title it.
And we're going to need to title it. So then that means this one's going to be gallons purchased or gallons bought.
Did that go by?
Here, I'm going to rewrite gallons because that looks ugly. And on that one, I went, every other one was 1. So I went by halves. Okay, so 1 doesn't start till here, and then I did 2, 3. Because when I look at the data, I notice that there it goes from like 1.1 to 2.8 is the biggest one. So I know I'm going to have to use fractions or decimals. So I really don't need my data, my y-axis to go that high. So I just did, each one was half. Jonah.
I just got a question.
Okay. Okay, so we do have to title the graph. What are we going to title this graph, guys?
That was so much.
I would title it gasoline purchases or gas purchases. I know I didn't leave you a lot of room. But I'm making a big deal out of the titles of your graphs, so make sure you title them. Okay, so basically, this should be pretty easy for you because we've done stuff like this before, right? This is just a T-chart or a table where we have our X's, which is dollars spent, and our Y's, which is gallons bought. So you're just going to put a point for every XY ordered pair that you see. So dollars spent, when I spend $10, I get 2.5 gallons of gasoline. So I'm going to go 10, 2.5, which is right here. And I'm going to make my dot just a smidge smaller. That's kind of big. Then we do 11 and 2.8. So there is going to be some in between. 2.8 is probably right there. So you're going to do a little bit of estimating, but that's okay. 9 and 2.3, which is like right here. 10 and 2.6. So this person must have bought their gas somewhere else because they, oops, that's a little high. Probably somewhere right there because they spent the same amount but got a little bit more. So gas was a smidgen cheaper for that second person. 13 and 3.3. So that's somewhere right here. 5 and 1.3. So that's about right here. 8 and 2.2, so 2.2 maybe there. And 4 and 1.1, which is like really close to 1. So something like that. So our data is scattered, but it is pretty close to forming a line, right? So would this have a higher or a correlation coefficient of positive or negative? Let's start with that. Good, positive because it shows it's going up. And would this be closer to 1 or further away from 1? Closer to 1 because it's like pretty straight. I mean, this would be like 0.99. Like it's pretty straight. The only question that I want you to answer for right now is what type of correlation does this show?
Positive.
It is a positive correlation. And I want you to explain it to me. So I graded your quizzes. I thought I was going to have enough time I probably will have enough time to pass them back. But my biggest thing, for the most part, you guys did really great, but my biggest thing was in your explanation, some of you just answered the question in one word. Or like you didn't elaborate. You need to explain why. So I would say that the data shows a positive correlation.
Oh shoot, I didn't elaborate.
Why? Why is this a positive correlation? Jen. Okay, that's a very non-mathematical way of explaining it. Lily. Because X and Y are both increasing. I'm going to ask you to get even a little more specific. What does X represent?
Because
Dollars spent. And what does Y represent? Gallons bought. So we can say that it shows a positive correlation because as the dollars spent or as the amount spent, and I know I didn't give you a lot of space, increases. So we want to say increases instead of goes up. Increases. What else increases? the amount of gallons of gas you get, right? So we can just say the amount of gas you get also increases. I'm sorry I didn't give you enough space for that. You guys can squish it. Okay? So this would be a complete explanation. The data shows a positive correlation. We don't really need a comma there. Because as the amount spent increases, the amount of gas you get also increases. So that is a complete explanation as to why. Okay? So our next step in all of this would then be to calculate the line of best fit or the trend line for this data so that we could make some predictions. When we do it by hand, we call it a trend line because it's not as exact. When the calculator does it for you, we call it line of best fit because it's a machine and way more powerful than our brains and it can get super exact. So that's why we kind of use both interchangeably. That's why on this next one it says how to calculate a trend line because you're going to do it by hand. Mostly we call it line of best fit though. Okay? So that would be our next step is what equation represents this data so that we can make some predictions. So if, say, I only have $20 to spend on gas, how much gas can I get for $20? If we had an equation, we could estimate that. Make sense? Okay. So we will do that piece tomorrow. So for today, I'm just going to leave you with this.